Hey guys, in this video I'm gonna be explaining how to hack Cronus, um, so that if there is a class on the system, so you just delete it and then it doesn't appear on the system, and then you don't have to go to class. Oh wait, remember this semester it happened a few times and I wonder why. Oh what? Okay. Oh wait, I'm gonna be explaining how to hack ACDC and get the badge, super secret. Do you want that badge? Oh, what? What did you say? Can you repeat? Oh, oh, you said exercise 10. Okay, okay, I'm gonna be explaining exercise 10 in this video. Okay, but not all of them. Only from 1 to 4. Okay, are you ready? So again, before we start, I want you to know these formulas, right? Like you must know this. You must memorize this. This is how you memorize. You need to write this 5 times. And then if you need more advice, watch exercise 8, exercise 9 functions, previous videos. And now you have to know this. And I explained this on the previous videos. And then based on this, we're going to be solving exercise 10. Okay, let me put this paper here. And then so we have exercise 10. Before I start this, let me explain you what's the difference between exercise 9 and 10. In exercise 9, they tell you up to which order to calculate. For example, find it up to the second order or third or maybe 5 or 6. But in this question, you need to calculate the limit. But in order to calculate the limit, we need to use Taylor expansion. But the thing is, we don't really know up to which point uh, to calculate, like second order. Are we gonna use second order or third order? So what I'm gonna be doing is I'm not gonna be giving you the solution right away, because my goal is to teach you how to get the full score on the final test. And it's easy. This question is easier than 9 and 8. Okay, um, so let's start. So we have this, and I'm gonna write this as 1 plus a over x. If you calculate limit, so writing it in Taylor format, Taylor expansion format, it helps. So we try to use Taylor expansions right here to find limit. That's why I love TE. TE means Taylor expansion. So this one, we can write this as e to the x ln 1 plus ax. If you understand, that's fine, but there are some people who don't understand this, so I'm going to be mentioning the formula right here. Oh, it's a is this, and then if it's ab, no, this is for 10, this formula different. A to the b is equal to, what is it? B ln a. So I use this formula, and then I'm mentioning this formula as well because I'll use this 1 plus u plus ou. Okay, can you see it? Yes, I will focus it. Okay, now let's continue. So right here we have this one, and imagine this is like x, like in the formula it's like u here, and you must write u tends to 0. It's important. It means that you can use the formula. So we're gonna take the first order here. So x to the, it's gonna be what? U is a over x, right? Plus I'm using this formula. This is plus ou, and ou a divided by x, but it's equal to based on, what is it, the properties, smaller properties. A over x is equal to 1 over x. You can deduce 1 over x like this with smaller notation. Okay, any questions? No? Good. And now here we multiply x into the parentheses, so we have a plus o to the 1. And here our goal is to get o1. I will tell you why after a bit. And then you can write this limit approaches to, limit is ea. So you can just write its limit is equal to ea on your answer. But let me explain you. I mean, if you write this from here to here on your final paper, you will get full score. you'll get full score. But right now, explanation point to find, because it's the first problem we're solving, to find limit in exercise 10, the goal is, for all the problems, the goal is to have accuracy of 1. This is the main idea for all, and that's why it's easy, because one formula for all problems. So if you have fx, something like this, you need to write this something f, for example, f plus or 1. So this is our main goal. I'm going to be doing this because it's the main goal. And then let me tell you, and then the next thing is, right now we took the order, Taylor expansion order up to the first order, right? I mean, we use this formula. But what happens if you take the second order? So in order to check, let me show you. Let's see what happens. Oh, I didn't take it before. If you have this one. So if you have ln 1 plus u, what's the second order? According to the formula, look at the formula number 5. It's equal to 1 minus 1 over 2 u square plus small o u square. So this is this formula. So according to this formula, e to the x and ln this is equal to a over x minus a square divided by 2x square plus o1 over x square. And if you multiply x in the bracket, you have e to the a divided a minus a square 2x plus o 1 over x. And do we have O1 here? No. That's why this is a problem. That's the reason why we don't want to take the second order Taylor expansion. Yeah. Okay, so that's it for number 1. And now, if you have any question, you can comment. But I'm not going to be replying anyway. Like number 2. So in number 2, again, always you write first, you try to simplify, you try to find the Taylor expression for this. So I'm gonna write it, but this is quite not complicated, but you have to think a little bit. So look, this is something that's going on in my mind right now. I have this one, so I need to have O1 at the end of the day, but like I don't know what to do now. So like my focus, what I'm thinking is like this. Like this is numerator and this is denominator, so I have n over x, like numerator divided by x. Let's say this is something that's going on in my mind. And then if n, let's say first case, if n is equal to something 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 plus O1, let's say the numerator, and then I will have to calculate n over x, and it's equal to something 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 plus O1 divided by x, right? Agree? Yes. And if you continue, this is equal to something 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 divided by x plus O1 divided by x. And if you continue, this one gives you, let's say it's just something we don't know, but this one can be written as O1 over x, like this. 100% sure you can use this, and then x goes inside. And then do we have O1? No, that's why it's a problem. So if I do this one, it's a problem for me. So number 2 case, it's something that's going on in my, what if numerator is this plus OX, right? Then numerator divided by x will be dot plus OX divided by x, and it's equal to dot divided by x, and OX divided by x is equal to O1. So I will have this one at the end. I'm not sure with this one right now, but I might have this one. That's why my goal is to take the first order in the numerator, to have OX in the numerator. That's my goal. That's how I got the idea in my mind first. But you don't need to write this on final. No need. So I'm gonna be doing this. So I continue from here to here. You just write here. You don't need to write this. There's something that's going in your mind. You should think like this if you want to get full point. Okay, now I just take numerator first. 1 plus x, 1 over x minus e. So this is equal to, first I try to calculate this one, so it's equal to e 1 over x 1 plus x minus e. Okay, I need ox in the I need ox in here. So look, if I take the first order here for ln, so I'm gonna be having what? I'm gonna be having let me see the formula, x plus ox minus e. And if you multiply this by 1 over x, it will be e to the 1 plus o. This is 1 over x times ox. It's going to be o1 minus e. But the thing is, right now, o1 is, what is it? It's in the power. I mean, if you use the Taylor expansion formula for this, o1 is in the power. Do we need o1 here? No. It's okay for numerator itself, but right now our goal is to have ox. Right now we don't have ox. That's why from ln to here we took the first order. So what do we do in order to have ox here? Okay, you skip this part again. This is not on, this doesn't have to be on the final paper. It's just I'm trying to teach you how to solve this. Right now from here to here I took the first order. Right now I try to take the second order. If you take the second order for ln, you need to have x minus 1 over, what was the formula, 1 over 2x squared plus ox squared minus e. Right now, if you multiply 1 over x in bracket, it's gonna be 1. Okay, I try to write bigger. Let me see, you can see it. Okay, you can see it, I hope. It's visible, I hope. It's 1 over 2x plus, this is gonna be ox, because 1 over x times x squared is equal to ox minus e. Now I continue, and here I cannot say this is all u, because if x and u goes to what? U goes to, it doesn't go to limit x. If x goes to 0, u doesn't go to, I mean this goes to 0, and 1 minus 0 goes to 1. That's why I cannot use the formula right here. If you use the formula right here, you will get you will lose points, so you don't want this. So you need to, what you can do is you write this as e to the 1 minus e minus 1 over 2 x plus ox, right, like this. And now right now you can say this is u, and you can write it tends to 0. And if for this, if you use the formula number 2, e is going to be 1 over 2 1 minus 1 over 2x plus ox. If you don't understand this part, watch the previous videos, because exercise 8, 9, 10, they are related to each other, connected. So you multiply e minus e over 2, ex over 2, and e times ox is gonna be ox minus e. You cancel e, and you have minus ex over 2 plus ox. So then I have n over x, right? Numerator divided by x. What is numerator? Minus e divided by 2 plus ox divided by x. Oh, ex here, I forgot. And this is equal to ex plus ox divided by x is equal to o1. And here, based on this, I can go here. The answer is minus e over 2. If you just write this and then this and then this, you will get full point, I am sure. Now next one, exercise 3. So in exercise 3, what do we have? We have cosine and x squared. So in this case, again, the first step is I take cosine 1 over x and then x squared, and I continue. What do I use? Because I have x squared in the power, I need to use e. So according to the previous formula I mentioned before, it's equal to e x squared ln cosine 1 over x So cosine x, right? Look, and now I try to explain a little bit more. I need to have O1, right? I mean, if I take the first order, I mean, this is u, right? If I take the first order for cosine, I'm gonna have O1 over x. But at the end, if I have O1 over x, if I multiply it by x squared, I'm going to have OX. My goal is to have O1. That's why I need to take the second order. Second order. And you might ask why? It's because of this. I'm just focusing on x squared. If it was 3, if it were 3, I would take the third order. If it were 5, I would take the fifth order. So right now, because I have x squared, I'm taking this first order ln, no, second order. For cosine, it's 1 minus 2 factorial x squared plus O 1 over O x squared, right? And you continue. Okay, and then in here, what can we do? What can we do? From here, you think you mentioned this is u, and then u tends to 0, right? U tends to 0. Why? Because x goes to infinity, and if you think this is u, this goes to what? Yes, it goes to 0. It means that you can use the formula right here. So you write x squared. If you use the formula for ln, you just take the first order because it's x squared. So for ln, you take the first order here first. Okay, and now if you take the first order, it's minus 1 over 2x squared plus O 1 over x squared. Okay, I'm still recording. And if you multiply x, if x squared goes inside, you are going to have minus 1 over 2 plus O 1. So you have e to the minus 1 over 2 plus O 1. So right now, you just write this, and then you say, so a limit of this is equal to e to the minus 1 over 2. You don't have to write any word. Don't write any word on your final, because you might mess up. Because if you write something wrong, and they're gonna be like, oh, he's wrong, the professors. So if you write this and this, that's gonna be okay. And now the last one, number 4. Are you ready? Okay, again, first step, it's easy. You have x cubed and sine 1 over x minus x squared. Again, let's think together. Now we solve this together. I'm gonna be asking questions, because goal is to teach you how to solve this, how to get the idea, because we're not gonna have the same question. Okay, right now I try to expand sine x, right? It's the first thing, because x cubed, x squared is just this. But sine x, we need to expand it. But which order? Which order? Now you tell me. Order 1, 2, 5, 3. Oh, did you just say 3? Oh, this is u. You need to mention u tends to 0. Okay? Which order? Third. Oh, nice. Third order. You don't have to write third. Why? It's because of this x cubed. Because it's 1 over x. I mean, they give it on purpose. 1 over x and x. If you have O 1 over x cubed, when you multiply it at the end, you will have this one, O1. That's why it's 1 over x. If it's 1 over x squared and it's x to the 4, you take the second order. Because, yes, now you understand. Do you understand here? It can be like this, like something extra for you. X to the 4 and sine 1 over x squared. In this case, you take the second order, because second order is going to give you O 1 over x to the 4, right? And then or let's just say it's 1 over x, and then you take the fourth order, not the second, fourth order, right? And it gives you O 1 over x to the 4. And now you know what to do, so let's do it. X cubed, you get the correct answer. So sine, which formula? It's formula number 4. Have a look at formula number 4. According to that, if you expand this, it's equal to this plus O x to the 4. Oh, it's 1 over x here. it's 1 over x, that's why 1 over x minus 1 over 3 factorial x cube, right, plus 1 over x to the 4. Am I right? Yes. Now we continue, we multiply it, and you have, now we have 1 over minus, why am I forgetting everything? Because I'm excited to finish this. X square minus 3 factorial x cube cancelled, 1 over 6 plus 1 and x square is equal to minus 1 over plus 1. The thing is, like, the problem, they want you to, it's easy, they made it easy because we have this one so that you can cancel this, 2 of them, but if you don't have this one, we are in trouble. So they want us to solve this problem, and you just stop here, and after this you just write this one, limit of this is equal to, in your answer you don't need to write this one, you just write minus 1 over 6, minus 1 over 6. So this is your final answer. And now if you want me to solve exercise 10, 5, 6, 7, 8, 9, 10, I want, in this video, I want 12 comments from 12 different people. Like, you just type something like yes, like yes, or make video or something from 12 different people, because no, it's just 12 is my favorite number. So that's it for this. This is gonna be official ending. Bye bye, guys.